children, welcome to Math Park. In our park, today we are going to learn the topic sequences. Very important topic, children. Keep watching. So let us understand what are you going to learn in this topic. So in this topic, you will be able to understand what are different types of sequences. You will be able to find the nth term of the sequence, and also you will be able to find any term of given sequence. Okay, so here we go. So what do you observe here? 1, 2, 3, 4, 5, 5, 7, 9, 11, 6, 12, 24, 48. What do you observe? Some pattern? Yes. What do you call such pattern? We call it as a sequence. Okay, so sequence is a list of numbers that follow some pattern or a rule. Sequence is a set of numbers that follow some pattern or a rule. So here you can see there is some pattern being followed. Now how this patterning is being followed? So you can see that 1, 2, 3, 4, 5, the number is increasing by 1 every time. 5, 7, 9, 11, the number is increasing by 2 every time. So this first two sequences, they have the common difference. So sequences with common difference, they are called as arithmetic sequences, or sequence with common difference, which is called as arithmetic sequence. Now, in the next example, you can see that the number is multiplying by 2. 6 into 2, 12. 12 into 2, 24. 24 into 2, 48. Okay. Then again here, what is happening? You are dividing by 2. So they are having a common ratio. So the sequences which have the common ratio, they are called the geometric sequences. The sequences with the common ratio, they are called the geometric sequences. Okay, so how do we find the ratio here, children? Look at this. So when we look at the common ratio, to find the common ratio, what do? We move to the next term. So 12 divided by 6, which is equal to 2. So this is the common ratio. Okay. Again here, 32 divided by 64, which is equal to 1 upon 2 is the common ratio here, R. And here we have a common difference. So you are adding 1. So the common difference here is equal to 1. Here you are adding 2 every time. So the common difference here is 2. So the sequences which have the common difference are called as arithmetic sequences. And the sequences which have the common ratio, they are called the geometric sequences. Okay, children. Now we understand further the type of questions. Now let us see the sequence in the diagram here. When look at these diagrams, observe it carefully. You observe some pattern. What's happening with the red tiles and white tiles? Please observe it carefully. Okay, so here are some patterns. So two types of rules, they describe the sequence. Okay, there are two types of rules which describe the sequence of the red tiles. How the red tiles, what is happening to the red tiles when it go into the next term. Okay, and what are these two types of rules? They are term to term rule and position to term rule. So the term to term rule, what does it do? It describes how to get from one term to another. Term to term rule describes how to get from one term to another, and position to term rule describes how to get from one position, how to calculate the term from its position in the sequence. It describes how to calculate the term from the position in the sequence. Okay. Now, so what is the term to term rule here? The number of red tile is increasing by 1, and the position to the term rule is what? The number of red tiles is always 2 more than the number of white tiles. So to understand how to frame the term to term rule and position to term rule, come on, let's move on. We take the same example once again. So here you have the same pattern. So what's happening to the red tiles and white tiles here? Which rule will help you to find out how many red tiles are needed for a pattern with 100 white tiles? Yes, it is position to term rule. And to find the position to term rule, or to derive the position to term rule, let us make a table. So what do you observe in this table, children? So in this table, you can see that how, according to the position, what is happening to the number of white tiles and number of white tiles. So the first position here, the white tile is 1 and red tiles are 3. 1, 2 and 3. In the second position, the white tiles are 2 and red tiles are 1, 2, 3, 4. In the third, there are white tiles are 3 and the red tiles are 1, 2, 3, 4 and 5. In the fourth, the white tiles are 4 and the red tiles are 6. So what is happening every time? You can see that white tile plus 2 is your red tiles. Number of white tiles plus 2 is your red tiles. So white tiles are increasing by 1 and red tiles are also increasing by 1, but it is plus 2 to the white tiles. Okay, so that is how we can decide that if there are 5 white tiles, so 5 plus 2, there will be 7 red tiles. Now, how can we decide whether for the 100 white tiles, how many red tiles can be there? So it becomes difficult if I go on writing this, okay, for the 100 positions. So it's easy if you frame an equation or frame the position to term rule here. So to frame the position to term rule, how do we understand here? So we can see that number of red tiles is equal to number of white tiles plus 2. So number of red tiles is equal to number of white tiles plus 2. So this is our position to term rule. This is our position to term rule here. So you can see how did you get this? So if I am going to put 100 tiles, white tiles here, so the number of red tiles are simply increasing by 200 plus 2, which is 102. Got it? So this is how we describe the position to term rule when the pattern is given. Similar questions are there in your textbook, children. Keep practicing to understand in a better way. Let's understand the number pattern. Now here you have a question. Work out the nth term rule for the sequence. Okay. Now what can you observe here? 6, 8, 10 and 12. So to work out the nth term rule in a sequence here, children, I'll tell you one idea. There is, what do you observe here? First of all, you should decide what type of sequence it is. Okay. So here what is happening every time you are adding 2. So adding 2. So the common difference here is plus 2. So the D is here plus 2. Okay, so one thing 2n for sure is going to be one of the part of your nth term. Okay, nth term rule. Now, if I put n is equal to 1, so I get 2. So 2 plus what gives me 6 the first term? So 2 plus 4 gives me 6. So 2n plus 4 is going to be our nth term rule. So that again you will understand when I'm going to show you with the help of formula here. So let us understand with the help of formula how to come to the nth term rule. So here is a formula. An is equal to a1 plus n minus 1 into d. So where your an is the nth term, a1 is the first term which is 6 over here, n is the position and d is the common difference which is 2. Now we substitute these values in the formula. So we get an is equal to 6 plus n minus 1 into 2. On solving this, we get 6 plus 2n minus 2. So what have we done here is we have simply opened the bracket, children. So what we do here, open the bracket. So what are we doing here? 2 into n, you got 2 into n, you got 2n, and 2 into minus 1, you got minus 2. And 6 minus 2 is 4. So that is how you got 2n plus 4. Same we did when I was explaining how the common difference was there. So did you understand how to find the nth term with the help of formula? Okay. Now let us add something more to this question. Okay. So we add something more to this question. So find the 150th term of the sequence. Now, if you have to find 150th term of this sequence, going on adding 2, 2, 2, 2, it becomes very lengthy. So the easiest way is if you have found the nth term, put n is equal to 150 here and you get the nth term. Or only if you are asked to find 150th term, simply put in this formula 150, put a1 in place of a1 the first term, put the common difference, then also you will get. Here, because you were asked to derive the nth term, so we went in this way. Okay, now finding the 150th term, we put 150 in place of n. So 150 into 2 is 300 and 300 plus 4, we get 304. Okay, so here we have seen the sequence, arithmetic sequence, and how to find the nth term and also the given term, any term of a sequence. Okay, let us take another question here. So in this question, find the term to term rule, nth term and 25th term of a sequence. Now, what is happening here? It is 46 minus, so what is happening here? It is decreasing, right? The sequence, it is decreasing. So if it is decreasing, then what is to be done? So what is the common difference here? To find the common difference, what we actually do is subtract next from the first. So 42 minus 46, which is minus 4. Or you can do 34 minus 38, which is equal to minus 4. So minus 4n for sure is going to be one part of your nth term. Okay. Now if I put n is equal to 1, so minus 4 into 1, I get 4. Now minus 4. So minus 4 plus what will give me the first term, which is 46. So I'll have to add here what? So minus 4 should be added to what to get 56, 46. So I should add 50. So my nth term becomes here 50 minus 4n. Okay. Now with the help of formula, how do we do it? Let's understand. Okay, let's understand how do we do it with the help of formula. So here we go, and term to term rule, as we have seen, subtract 4, and the formula again, an is equal to a1 plus n minus 1 into d. Substituting the values, what is a1 here? So a1 is 46, first term. Your common difference is minus 4, and then n minus 1. We simplify this. So when we are simplifying, means we are multiplying by minus 4 to the terms inside the bracket. So first we do this plus into minus is minus. So that is how 46 minus 4 in bracket n minus 1. Now we further simplify this, multiplying by minus 4 to each term in the bracket. Minus 4 into n is minus 4n, and minus 4 into minus 1 is plus 4. Now 46 plus 4 is 50, and this is how we get the nth term as 50 minus 4n. Understood, everybody? Okay, so once again, let us see what did we do here. We substituted the value of the first term, a1. So our a1 is what? 46. So we substituted 46 here. Our common difference is minus 4. We substituted minus 4 in place of d, and n minus 1. Minus 4 plus into minus becomes minus. Minus 4 into n is minus 4n, and minus 4 into minus 1 is plus 4. So 46 plus 4 is 50, and 50 minus 4n is our nth term. Okay, now let us understand how to find the 25th term. So for finding the 25th term, what do? We simply substitute the value of n in the place of value of 25, whatever term is asked. That is the position. N is the position. So 25th term. So in place of n, we substitute 25. So 4 into 25 is 100. And that is how we get the 25th term as 50 minus 100, which is equal to minus 50. Got it? So we have seen two questions such that where the common difference was positive, and here the common difference was negative. Watch again to understand better, children. You can pause, rewind, and watch again to understand it better. Okay, now let us move ahead with the next question. Okay, so now what is happening here? Find the term to term rule, nth term and 10th term of a sequence, 6, 12, 24, and 48. Tell me what type of sequence it is. Yes, what type of sequence it is? What is happening here every time? So to go to the next term, we are multiplying by 2, multiplying by 2. So this type of sequence where there is a common ratio are called geometric sequences. These are called geometric sequences. And how to find the common ratio? So R is equal to the next term divided by the first term. So 12 divided by 6, which is 2, is our R. Or you can take 24 divided by 12, which is again 2, is your R. That is the common ratio. Now with the help of formula, how are we going to find? So it is easy to frame the nth term with the help of formula. So let us understand how to frame the nth term with the help of formula. And the formula for a geometric sequence here is an is equal to a1 r into bracket r raised to n minus 1. a1 r raised to n minus 1. So let us understand each of thing what they are. So an is our nth term. An is our nth term. Then your r is the common ratio. A1 is the first term, which is given 6 here. N is the position, and R is the common ratio, which is 12 divided by 6, which is 2. I just showed you how to calculate the common ratio with other values as well. Let us substitute these values. So in place of A1, we have put 6. Okay, R is 2 raised to n minus 1. So this is our nth term of the sequence. This is our nth term of the sequence. Okay. To find the 10th term, what we'll do, in place of n, we'll just put 10, the position. Okay, substituting 10 in place of n, what do we get? 10 minus 1 is 9, and 2 to the power 9 is 512. So 6 into 512, that is going to be our 10th term. Okay, which is 3072. Okay, let's understand how did we go about. Okay, so what did we do here? So first thing, we understood that it is a geometric sequence because there is a common ratio 2. Formula for finding the nth term is an is equal to an is equal to a1 r raised to n minus 1, where r is the common ratio, 6 is our the first term, 2 is the common ratio raised to n minus 1. This is our nth term. This is our nth term of a sequence. To find the 10th term, we just substitute in place of n 10. So 2 raised to 10 minus 1, which is 2 raised to 9. 2 raised to 9, when you calculate 2 multiplied, 9 times, you get 512. And 2 into 512, which is 3072, is your 10th term of given sequence. Okay. Now this was easy, geometric sequence. Remember the formula. Okay. Watch again to understand it better. Okay. Let us move on to the next question. One more last question. So here again, what you observe? What are you observing here? So what is happening? There the sequence was increasing. The number was increasing. Here in this pattern, the number is decreasing. So how is it decreasing? What is the relation here? So this relation, how you find the ratio? It is 64 divided by 2. It is 32 divided by 2, you get 16. So to find the common ratio, we get the second term divided by the first term. So it is 32 divided by 64, which is equal to 1 by 2. Or you can take 8 divided by 16, which is again 1 by 2. So this is our R. Okay. Now we go for a formula. What is our formula to find the nth term? So the formula is an is equal to a1 in bracket r raised to n minus 1. Let's substitute the values here. So value of a1 is 64, the first term. An is the nth term. A1 first term is 64. R the common ratio is 1 by 2. And n is the position. Okay. Let's substitute. So we get the nth term as 64 in bracket 1 by 2 raised to n minus 1. Okay. This is your nth term. Okay. To find the 10th term, in place of 10, simply we'll be putting the value 10. So A10 or 10th term is equal to 64 into half, which is r raised to 10 minus 1. So 10 minus 1 is 9. So half raised to 9 is equal to, so it is actually 1 raised to 9 upon 2 raised to 9. So 2 raised to 9 is 512, and 1 into 64 is 64, and 64 divided by 512 is 1 by 8. Okay, so what did we do here, children? We substituted the values in the given equation and we found the values. Now look here, it is 1 upon 2 raised to 9, which is actually 1 raised to 9 upon 2 raised to 9. Now 1 raised to 9 is 1. Okay, 1 raised to 9 is 1. So what did we see here, children? 1 upon 2 raised to 9 is 1 raised to 9 upon 2 raised to 9. So 1 raised to 9 is nothing but 1, and 2 raised to 9 is 512. Okay, so it is 1 upon 512. So 64 into 1 upon 512 is nothing but 64 upon 512. So on simplifying this, we get as 1 upon 8. Okay, children, please watch again to understand it in a better way. Watch again to understand in a better way. And if you like the video, don't forget to share with your friends.